So welcome to this video on pathfinding. Today I'm going to be showing you how to do A-star pathfinding. Yeah, I just want to say before you look at this tutorial, I recommend you already watch another tutorial on YouTube or just read up on how A-star works, because I'm just not going to be explaining that right now. I'm just going to show you how to do it in Gamemaker. So the first thing you'll need to do is to go into your sprites and create these sprites. You know, obj.A, obj.B, SPR wall, SPR underscore node, SPR node activated, SPR underscore we are creating, and SPR underscore path. Name them the way I've done them, and yeah, maybe pause the video, create these. Yeah, they're all gonna be 32 on their width and height, and we're just gonna put their center to 0 on all of them. Okay, now that you've done that, create these objects. So we're obj.A. Visible, depth of -5. Obj.B is also going to be visible and have a depth of 5 instead. And obj wall is going to be visible and be a solid. Obj underscore node is also going to be a solid. So yeah, okay. Create these objects. When you can maybe pause the video, do that. I don't know. Now create a room. You might want to like put out a few walls for the pathfinding. Put out obj.A and obj.B somewhere, doesn't matter where you put them, because it's pathfinding and we'll always find the path. Just want to remind you that A-star pathfinding doesn't always find the shortest path, but it most often does it. But it will 100% of the time find a path. Doesn't matter how big your maze is, it'll always do that. Okay, create these scripts. skr underscore pathfinding and skr underscore node creation code. Okay, don't put any code in those yet, we're gonna do that later. Okay, go into obj.A and go into the create event. Create a create event. First, create an open array. This is going to be the array of the nodes that are going to be open and the ones that are going to be closed. Create a node array. It's going to be just all of the nodes we're going to have in total, you know. And the lowest value is we're just going to set that to something really high, because it's going to be used for the node with the lowest F cost. That's going to be the one that we're going to be updating. I is going to be used to see the size of all of the nodes. We'll just put that to 0. The size of the array. Just put that to 0 right now. The current node is going to be used to see which node that is updating. Put that to yourself now that we program in obj underscore point A. So just put that to obj underscore point A, because this one is going to be the one that's going to be creating nodes around itself, and then it's going to be keeping going. Can create equals true right now. Can create is later going to be equal to false when one of the nodes have reached the target node. Just put that to true right now. Previous is later going to be used for so let's say that you have these are the nodes. Do not do this. Let's say that the nodes have found this one, created this one, and then just all these nodes created like this way, and the node who reached obj.B is going to check who created it. It's going to be this one, and this one is going to check where it came from. Came from that one, and where that one came from. It keeps on going back and back and back until it finds obj.A. So basically what this algorithm is doing is going from obj.A to point B, and then back to point A to see where the path is. Okay, great. So yeah, previous, just put that to self right now, and grid size. Since our sprites have a 32 by 32 width and height, we're just gonna put that to 32 right now. Now going to the step event. Here all you're gonna do is put script underscore execute skr underscore pathfinding. Okay, do that. Now go to that script. In skr underscore pathfinding, you're gonna copy this code from the description or just write it in. So okay, it starts like this. So if the target node has been found, stop the algorithm. So if current.x equals the target node.x and the y equals target node.y, we're going to put can create equals false, like I talked about earlier. And now, since that's not true in the beginning, we're going to do all of this big part. Okay, so we're going to now go to lowest value object. Lowest value of all of these are just going to be used to check like which node is going to have the lowest value and which one we're going to update and stuff. So lowest value object, this one is later going to be used to see which node we're going to be updating. Just put that to itself right now. So each time this loops through, we just want to reset all of these 4 variables. All of these. Because it's going to be, just want to reset those. So lowest value object, put that to yourself, or j.a, just do that for now. Lowest open, put that to 0 right now. I'll explain that later. Lowest value, put that to a really high number, because we're later going to use it to see what is called the node with the lowest f cost, and we're going to update that one. And lowest h cost is going to be used if the nodes.f cost, if the node's f cost is equal to the lowest value. We're going to just, if there are two nodes with the same f cost, we're going to update the one with the lowest h cost. So okay, now to creating nodes. Let's start with this one over here. If it's placed free to the right, so like no wall to the right or no other node to the right, we're gonna do all of this. So I plus plus, so now the first time I is gonna be equal to 1, and it's gonna be 2, 3, 4, and then next time it loops through 5, 6, and you know, keeps on going. I plus plus, nodes I equals instance create current.x plus grid size. So we're gonna create a new node to from the current node x to the right. So I'm just gonna do that. And we're also gonna do script underscore execute skr underscore node creation code. So okay, now going to script the creation code script. Here we're gonna do the g cost, h cost, f cost, and previous, and also the open. So node I.g cost is gonna be its distance from itself to the starting node, and its h cost is going to be its distance from itself to the target node, and the f cost is going to be its g cost plus h cost. So okay, and its previous going to be the current, so its parent is going to be the current node because it got created by the current node. It's also going to be open. This one's open, it's not been the current node ever, so we're just going to put that to open. So open I equals true. Okay, go back to skr underscore pathfinding, and yeah, we're gonna do the same thing, but for, you know, right, left, up, and down. So yeah, now we're gonna check for the one with the lowest f cost. So we're gonna see which one's later gonna become the target node. So we're gonna put a new variable, k equals 0 if k is less than I, k plus plus. Since k is less than I, we're gonna just put, you know, do all of this. And if open k equals true, so if it's open, we're gonna do all of this in here. So nodes k.f cost, if it's lower than the lowest value, then we're gonna do all of this. So basically the node with the lowest f cost is gonna become the new current node. So now that we've done that, lowest value equals nodes k.f cost, and lowest value object is going to be nodes k, and lowest open is going to be k. So let's say that k equaled 3, so it was the third node, then open k is going to be 3. If nodes k.f cost is equal to the lowest value, so if there are two nodes that have the same f cost for say, we're going to take the node, we're going to update the node with the lowest h cost. So if that node .h cost is lower than the lowest h cost, then we're going to do all of this in here. Lowest value object equals nodes k, and lowest value open is also going to be equal to k. It's the same thing as up there, but without the lowest setting the lowest value. Okay, and don't forget to put I plus 1 over here. If k equals I, so if we loop through the entire thing, we're going to do the thing in here. We're going to check. The new current that we're going to be using is going to be equal to the lowest value object. So we're going to do that, and the current.sprite index is going to be skr underscore spr underscore node activated. So it's going to be using this one, the later one that becomes the new current. You know. So yeah, and it's going to be what it's called. Also setting that one's open to false, because we've already used that now. And also, can create equals true. When this equals false, we're gonna start, you know, looping back to see where the path is actually gonna be. So that the node that's found, the target node, is gonna check its previous, so where it came from. It's gonna check its parent. So previous equals current.previous. So it's gonna be the current node's previous nodes, because you know every single node created another node. Yeah, like this one created that one, created that one, created that one, created that one, and the one that reached there is gonna check its previous. Yeah. So we're gonna do that, and we're also gonna put we want to repeat through all of this over here, but we don't want to. But since we don't know how big the path is, we're just gonna put p equals 0 if p is less than 1. P equals p, so it's never gonna be updating, except when the previous dot x equals obj dot a point x, and the previous dot y is gonna be obj point a dot y. So the node's gonna go to. So the A node is gonna create nodes to obj point B, and it's gonna loop back to obj point A. So when it's done that, we're gonna set p to 2. Previous equals previous dot previous. This is just setting r's previous value to use later for you know going back. Previous equals previous to previous, and previous dot sprite index is gonna be equal to spr underscore path. So we're gonna set the sprite index of the, because you know for every single thing that we're creating the path for, we want to see where the path is actually going. So we're just gonna put this, yeah, because this is spr underscore path. Okay, I think that's it, guys. Hope you found this tutorial useful. And when you've done it all, it's gonna look something like this. Yeah. And there it is. It's gonna be creating nodes, and then when it's found the path, it's most often gonna have the shortest path, but not always. It's gonna create the path to obj point B and go back. So yeah, guys, hope you found this tutorial useful, and peace out. Bye.